So I welcome you to Module 4 entitled Physical Layer. In this module, we are to tackle all about physical layer, its characteristics. One component that falls under this layer are our cables. We'll tackle details on our cables, twisted pair, coaxial, fiber optic, and aside from our cable, wireless also falls under this layer. Okay. So again, main purpose of this layer is to provide the physical connection to our end devices, and that is our cable, if it's wired or wireless, no? So, uh, basically, we can obviously we consider there's always a physical connection, whether if it's at home or in office or in an enterprise or even in telco. Okay. Use the specific component in our laptop or computer that connects our cables is the LAN card. Our computer or laptop nowadays usually has two LAN cards. One is for the wire, the other one is for the wireless. Or it may have, it may even have, there are even um, computers that has, say, two LAN cards or more. Okay, two wired LAN cards or two wireless LAN cards or more for whatever purposes there is. Okay. Um, in terms of uh, our cables, they differ on in their characteristics and in their performance. So that's our agenda. That's what we are to find out in this discussion. One concept behind the physical layer is it transmits bits. Bits are um, ones and zeros. No? So there is this ones and zeros that flows through our cables. Literally, it's not ones and zeros. No, ones and zeros are representation of the nature of the signal that flows through our cable. Technically, like it represents the current flow. Okay, so so again, there's these ones and zeros. No, the signal that transmits to our cables, and the first component that receives this in our end devices. Let's say um, in this side of our web client, say there's a data that flows from the server going to the web client. So again, there are ones and zeros, okay, streams of ones and zeros. These are our data. So the moment that the web client receives this, the specific component that receives that is the LAN card. Okay, so the LAN card, as we mentioned in module 3, it is a component of the data link layer. What it will do is to encode. Okay, we will discuss later what encoding is. Okay, and then after encoding, okay, uh, it will undergo that process of encapsulation. Okay, if it's transmitting, no, like in this case, the web client will receive that, so it will undergo the process of de-encapsulation. It will read, uh, like for the LAN card, the MAC address, okay, and then goes up to the different layers in the OSI. So let's look into some of the physical layer characteristics. Uh, Physical layer standards are governed by these organizations. Okay. Later we will discuss one standards developed by EIA-TIA. Okay, the way to create a straight through, a crossover, and a rollover. So that's one standard. So it's the one who come up with that standard is this EIA-TIA organization. Some organizations include those that are in these lists. When we talk about standards, specifically in the physical layer, it composed of the components. It lists down components. Example, if you were to manufacture twisted pair cable, okay, it lists down the materials to be used, specific wires to be used, the length, the diameter, the conductivity of the material, very detailed. Okay, you will see that in the standard. IEEE has that. During our live session, we'll look into this. Um, those acceptable encoding and signaling method uh, that a manufacturer may look into if they were to come up, if they were to manufacture a cable in this case. So there again in the component it includes the devices, hardware, okay, the media, and then I say the type of connector. In the encoding, it converts the stream of bits into a format recognizable by the next device in the path. It is in the encoding where the LAN card will interpret the 0 and the 1s. There are different encoding mechanisms. It is discussed in your computer organization and architecture. Okay. Um, like for example, Manchester. This diagram here is Manchester. Like in the Manchester, away 0 is interpreted, away 0 and 1s are interpreted, is the Manchester encoding will read the signal at the middle of each bit period. Okay, that is if there is a falling voltage or a drop in the voltage, okay, like this one, there is a drop here, okay, or from high to low, that's what we mean by drop, it will be interpreted as 0. And if there is a rising voltage, so if there is a uh, an increase in the signal from low to high, it will be interpreted as a 1. Okay, so in this discussion, very important that you are well aware of the term encoding. Okay, different encoding techniques is beyond our scope. It is usually discussed in detail for students who are taking electronics engineering courses. In the signaling, okay, in the signaling method, which is then again processed in the LAN card, this is how the bits, values, and ones are represented in the physical medium. If you look, we usually see this form and we say this is the digital signal, okay? But you know what, in reality, there's that what there's this device we call as an oscilloscope that is where you can see the actual signal. It doesn't look like this, okay? This is not the ideal. This is the ideal scenario, okay? Usually, it looks like, say for example, like similar to this one. So how can we say that a specific part or chunk here is a 1 or as a 0? So there are signaling technique. Okay. In electronics engineering, they apply mathematical technique for that. Again, that is beyond our scope. Okay. Very important that you are well aware of how to define signaling. Okay. Um, there, okay. Take note also that in our computer, our computer can process audio signal, okay, and usually audio signal are in this form. And take note that our computer is in digital, like in this form, okay. So also in the signaling is how are these being interpreted? That's the idea about signaling. And like in electronics engineering, they are taught of this modulation technique, AM, FM, PM. Amplitude modulation, frequency modulation, and then the phase modulation. That is beyond our scope. In electronics engineering, that's already a one course. Okay, but at least in here, you are well aware of the term modulation.